Hello, hi. We're going to talk about circular motion. I wasn't informed where exactly you stopped, so we are going to start a real quick recap of circular motion. Okay, and under that we are going to talk about radians. So radians, this is the angle subtended at the center of a circular path by an arc. Basically, it's called a radian. So radians are mainly used when we are describing angular displacement. So displacement that keeps on changing based on angles is called angular displacement. But this one is very common with objects moving in a circular path. Okay, so when an object is moving in a circular path, it undergoes what we call angular displacement, and the angular displacement is always measured in radians. Okay, so angular displacement can be calculated using this relationship. So this is change in angle is change in displacement divided by the radius of the circular path. Okay, so this here is called the angular displacement. Okay, we've started from the basics, so we shall continue to the complex parts. So this here is always the length of the arc, Sometimes you can say distance traveled around the circle or the circular path. Okay, so distance around the circular path, and since it is distance, it is always measured in meters. Okay, and then this, it is measured in radians. And then for the R is the radius of the circle. Radius of the circle or of the circular path. Since it is radius, it is also measured in meters. So basically, this is the first thing you need to know about circular motion. Now another note is that radians are written in terms of pi. They are written in terms of pi. Pi as in the one you see on a calculator. The only difference is that here pi means something else. It doesn't mean 3.14 just like it always means in many calculations. Okay, so pi, the moment you put pi with this RAD, someone will know you're not going to use 3.142. So pi is equivalent to 180 degrees. Okay, and then for complete oscillation or for complete vibration, okay, for a complete vibration / for a complete circle, you can always make these notes in your notebook. This is 360 degrees. Okay, but 360 degrees, I'll explain how this comes about. You know how a circle is 360 degrees, so moving around the circle means you're moving around its circumference. Okay, so basically we can now say the circumference of the circle, yeah, divided by the radius of the circle. So the circumference divided by the radius of the circle. So we know that the formula for circumference of a circle is 2 pi r, and the radius is also represented by r. So if we cancel out, then that means that we are getting 2 pi. So 360 degrees are equivalent to 2 pi rads, while pi rad is 180 degrees. So basically this is the relationship that we shall be talking about bit by bit. So in order to continue with this, we need to learn how to convert these different angles, like from degrees to radians, from radians to degrees, which I believe you can, having got this part here. You can always convert. Okay, so I'll record this lesson in very short videos until we finish up circular motion. Right, so this is the first part of circular motion. I'll end it with an example. I got an example just to help you convert, so I'll just move it aside and I'll write it here. So this is a quick one example. Convert pi over 3 radians to degrees. Just created this question. So we know that pi radians is 180. So this is the solution basically I'm trying to use there. Alright, so pi rad is, you always have to put the RAD to show that this pi is not the 3.142 that everyone is used to. So pi rad is 180. So if we need to know how much radians are in 1 degree, we have to divide by 180. So now this is 1 degree is pi over 180 degrees. Okay, this is 1. So if we need pi over 3 rads, okay, so it will be, we just divided by pi over 180. Okay, so dividing this and using math, we shall now have this times 180 over pi. The pi cancels out. Now we have 180 divided by 3, which gives us 60 degrees. So pi over 3 rads will give us 60 degrees. Sometimes you can even do this in your mind and get the answer, but sometimes the working is required. So basically this is the first part of circular motion. We have learned about the unit of angular displacement, and we have learned about the conversion from radians to degrees and from degrees to radians. Example, I can create another example here. Example 2, convert, maybe you can say 65 degrees into radians. So if we want to convert this, we can just start by saying 1 degree is pi over 180. So 65 will be pi over 180 and 65. And the answer you get will be in, you just put the word rad. You can use a calculator at this stage, and then you just put the word rad there to show that it is now into radians. So basically this is the first step. I hope you understood, and I hope this helps. I don't know if you've covered this already, but I'm going to continue in the next part with circular motion. Thank you very much, and have a nice time.